Good day everyone, my name is Nikatyan Pitayani. Today I will be presenting an advanced study on biochemistry, specifically focusing on bioenergetic and strategic metabolic problem solving. First, we look at proton leak. Certain drugs can increase membrane fluidity, which causes proton to leak across the inner mitochondrial membrane. This leads to uncoupling where the electron transport chain continues but ATP synthesis drops significantly. To engineer cell to use acetate as a primary fuel, we must upregulate enzymes like ACSS2 and transporter like MCT1. However, we must be careful of metabolic acidosis, as acetate accumulation can lower cellular pH. In G6PD deficiency, red blood cells cannot regenerate NADPH, making them vulnerable to oxidative stress. Since antioxidants are not enough, we explore bypassing his bulk using the EDH1 pathway or using CRISPR to repair the genetic defect. Cancer cells prefer aerobic glycolysis or OXPHOS. This is known as the Warburg effect. Although less efficient in ATP glucose, it is much faster and provides necessary building blocks for rapid cell division. For type 2 diabetes, we need to control glucose production in the liver without causing hypoglycemia. By targeting liver-specific enzyme or using allosteric modulator, we can achieve better glucose balance. A mutation in the alpha-KGDH enzyme disrupts the Krebs cycle. This leads to an ATP deficit and build-up of toxic intermediate. Treatment involves high-dose cofactors like thiamine and replacing the cycle via glutamate. It's vital to distinguish between adaptive ketosis and pathological ketoacidosis. Ketosis is a normal metabolic state during fasting, while ketoacidosis is a life-threatening condition caused by a total lack of insulin. In plants, phosphorespiration wastes energy. We can fix this biotechnologically by creating a glycolipid bypass. This allows plants to recover carbon more efficiently, potentially increasing crop yields in hot climates. Targeting PFK1 in cancer can cause muscle fatigue because muscle cells also use PFK. The solution is to design drugs that only target specific isoform bonds in tumors, sparing the muscle. The future of bioenergetics lies in mitochondrial replacement therapy, CRISPR-based gene editing for mtDNA, and smart nanocarrier to deliver antioxidants directly into the mitochondria.